For number 9, we're told that a coil of inductance, 93 millihenries in unknown resistance, and a 1.3 microfarad capacitor are connected in a series with an alternating EMF of frequency 1100 Hz. If the phase constant between the applied voltage and the current is 73 degrees, what is the resistance of the coil? We can start by writing down some of the things that we're given. First, we are told that we have a coil of inductance, and inductance is represented as L, and we're setting that equal to 93 millihenries. We have resistance, which is just going to be R, and that is unknown. We need to find the resistance, so that's why that's okay being unknown. And next we have a capacitor, and just as inductance is L, capacitor is C, and this is going to be 1.3 microfarads. Lastly, we have alternating EMF of 1100 Hertz. This is all the information that we're given, and we can now use a formula to look at how we're going to solve this. The formula is tangent phase shift is equal to X of inductance minus X of capacitance over resistance. In here, we don't have an X of L and an X of C explicitly, so we're going to have to break those down and say that our X of L is equal to L times omega. We don't have omega, so we're going to have to break it down further and say this is equal to L times 2 pi of F, with F being frequency. Next, we can also break down X of C, which is capacitance, and we're going to break that down to be 1 over C omega. We don't have omega, as we stated previously, so this is just going to turn into 1 over C times 2 pi of F, with F still being the frequency. Now that we have this written down, we can start and solve. We can solve for X of L first, and we will write that our X of L is equal to L, and our L is our inductance, which is 93 millihenries. We need to convert this into henries, so we're going to multiply it by 10 to the negative 3. Next, we have to multiply this by 2 pi, and then after this, we need to multiply the frequency in, which is 1100 Hertz. We can plug this into our calculator, and we are going to get the value of approximately 643. If we're solving for X of C, we are going to have 1 over our C, which is 1.3 microfarads. We need to convert this to farads, so we're going to have 1.3 times 10 negative 6 farads. And then this is going to be multiplied by 2 pi times the frequency, which is 1100 Hertz. After we do this, we're going to get the approximate answer of 111. Now we have our X of C and X of L. We can rewrite this formula right here so that R is on the top right or top left. It just needs to be on the top. It needs to be by itself so we can solve for this. And we're going to have R is equal to X of L minus X of C all over tangent of the phase shift. Plugging in our values, we're going to see that we have X of L, which is approximately 643 minus approximately 111, and this is all going to be over tangent and the phase shift in here, and our phase shift is 73 right here. If our calculator is in degrees, because we were solving for degrees, we're going to get approximately R is equal to 163. Since it's resistance, it's going to be ohms. And that is the work and answer.